Hey guys, this is Easy to Read. I'm Yashwant. Welcome back to another part of geometry. Today we will be learning about transversal lines, perpendicular transversal lines, properties of transversal lines, corresponding angles, consecutive interior angles, consecutive exterior angles, alternate interior angles, and alternate exterior angles. Now let's learn about transversal lines. A transversal line is a line that passes through two lines in the same plane at two distinct points. Example, in this figure, line EF is a transversal line because this line passes through two lines, line AB and line CD. When they pass, they will always form angles. In this figure, this line EF is a transversal line because this line passes through two lines, line AB and line CD. Now let's look at some examples. Let's see what's the transversal line here. A transversal line here can be AB because AB passes through two lines, GH and EF. Another transversal line could be CD because this line passes through EF and GH. And in this figure, EF is a transversal line because it passes through these two lines, AB and CD. And here, line AB is a transversal line because it passes through two lines, line EF and line GH. And here, transversal line can also be line CD because it passes through two lines EF and GH. And in this figure, line AB and line CD could both be transversal lines because they both pass through two lines, line EF and line GH. Now let's draw a diagram. Now let's name the lines. Line A, B, C, D, and E, F. Can you see the transversal line here? The transversal line here is line AB because it passes through two lines, C, D, and E, F. Let's draw another diagram. Now let's name them. Line A, B, C, D, E, F, G, H. Now let's see what is a transversal line. There are many options here. AB can be a transversal line, CD can be a transversal line, FE can be a transversal line, and GH can be a transversal line because all of these cross through two lines, either A, B, C, D, or F, E, G, H. Now let's learn about perpendicular transversal lines. A perpendicular transversal line is a line that passes through two parallel lines at right angles in the same plane at two distinct points. Example, this is a perpendicular transversal line because this transversal line crosses through two parallel lines and they form right angles when they intersect. Here, angle 1, 2, 3, 4, 5, 6, 7, 8 is equal to 90 degrees. Let's look at some examples of the perpendicular transversal. Here, this is a perpendicular transversal because line AB, which is a transversal line, crosses these two parallel lines and they intersect at right angles. Here, there are multiple transversal lines, but this is a perpendicular transversal because all the lines are parallel and all of them form 90 degrees. In this figure, the transversal line is EF, and it passes through two lines that are parallel and they form right angles as they intersect. So this is a perpendicular transversal. Here, this is also a perpendicular transversal because this line, AB, passes through two parallel lines, C, D, and EF, at right angles. Now, let's draw a perpendicular transversal. This is a perpendicular transversal because this line crosses the parallel lines and intersects these lines at 90 degrees. Let's look at another. This is a perpendicular transversal too, because this figure has all right angles and all of the lines pass through parallel lines. Now let's learn the properties of transversal line. When a transversal line crosses parallel lines, the corresponding angles around each intersection are equal in measure. Example, in this figure, this transversal line crosses through two parallel lines. That's why the corresponding angles are equal. Now, let's see about the angles. We know that angle 1 and angle 4 are vertical angles, and angle 5 and angle 8 are vertical angles. And we also know that angle 2 and angle 3 are vertical angles, and angle 6 and angle 7 are vertical angles. That explains why these are equal. Now let's draw a figure. Now let's see the properties of this transversal line. We know that the corresponding angles will be equal. So that means this angle and this angle will be equal. And this angle and this angle will be equal. This angle and this angle will be equal. This angle and this angle will be equal. Do you see something else? These transversal lines form vertical angles. Now let's learn about the transversal line crossing non-parallel lines. The corresponding angles around each intersection are not equal in measure. And here, in this figure, angle 2 and angle 5 are not equal to each other. Neither is angle 1 and angle 6. But even though if they don't cross if they don't cross parallel lines, they will still have vertical angles. Angle 1 and angle 4 are vertical angles, 2 and 3 are vertical angles, 5, 8 are vertical angles, and 6 and 7 are vertical angles. Let's draw a transversal line. Here, the lines are not parallel, so that means this angle and this angle will not be equal, but they will still have vertical angles. That means this angle and this angle will be equal, this angle and this angle will be equal, this angle and this angle will be equal, this angle and this angle will be equal. Now, let's learn about corresponding angles. When two lines are crossed by another line, the angles in matching corners but on different vertices are called corresponding angles. Example, in this figure, angle 1 and angle 5 are corresponding angles because they are on the same matching corner but on different vertices. Angle 2 and angle 6 are corresponding angles because they are on the matching corner but on different vertices too. Angle 4 and angle 8 are corresponding angles, and angle 3 and angle 7 are corresponding angles. Now, let's see the properties of corresponding angles formed when transversal lines intersect non-parallel lines. Angle 1 and angle 5 are corresponding angles, but in non-parallel cases, they will not be the same value. Angle 4 and angle 7 are corresponding angles, 2 and 6 are corresponding angles, and 3 and 8 are corresponding angles. But even though if it is non-parallel, you will always see vertical angles. Let's see some more examples. Here, angle 3 and angle 7 are corresponding angles, but they are still not equal. 1 and 5 are corresponding angles, they're not equal. Angle 2 and angle 6 are corresponding angles, but they are not equal. And also, angle 4, angle 8 are also corresponding angles, but they are not equal. Here, the corresponding angles are angle 3 and angle 10, angle 1 and angle 7, angle 12 and angle 9, angle 13 and angle 14, angle 2 and angle 8, and angle 6 and angle 11. Here, not any of the lines are parallel, so none of the corresponding angles will be equal. Let's draw a figure. Now let's name these lines. Line A, B, C, D, E, and F. Now let's see the angles they are formed. This corresponding angle of this is here. Since they are not parallel, they will not be equal. The corresponding angle of this is here. As you see, this is also not equal because they are not parallel. Here and here are corresponding angles, and here are corresponding angles, but they are still not equal. Now let's see the properties of corresponding angles formed when transversal lines intersect parallel lines. When a transversal line intersects a parallel line, the corresponding angles will be equal. Here, angle 1 and angle 5 are corresponding angles, and they are equal. 2 and 6 are corresponding angles, 3 and 7 are corresponding angles, and 4 and 8 are corresponding angles. In this example, let's see the figure. Now let's point out all the corresponding angles. 1 and 9 are corresponding angles. 4 and 12, 3 and 11, 5 and 13, 6 and 14, 8 and 16, 2 and 10, and 7 and 15. Now all of these corresponding angles are equal because these transversal lines are crossing through parallel lines. Let's see another figure. In this example, the corresponding angles 1, 6, 4, 9, 3, 8, and 2, 7 are equal because this transversal line crosses through two parallel lines. Now let's draw an example. Now let's name these lines. Line A, B, C, D, E, F. And now let's point out the corresponding angles. The corresponding angles here is this angle and this angle. These angles are equal because this transversal line is crossing through parallel lines. This and this are corresponding angles. This and this is corresponding angles. This and this is corresponding angles. Now let's see the properties of corresponding angles formed when transversal lines intersect perpendicular to the lines. Example, all corresponding angles in perpendicular transversal is 90 degrees. Example, angle 1 and angle 5 are both 90 degrees. 2 and 6 is 90 degrees. 3, 7, and 4 and 8 are both 90 degrees. Let's see an example. Here, all the corresponding are right angled because this is a perpendicular transversal. Angle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is equal to 90 degrees, and 13, 14, 15, 16 is equal to 90 degrees. Here, these are 90 degrees, and all the corresponding angles are also 90 degrees because this is a perpendicular transversal. Angle 1, 2, 3, 4, and 5, 6, 7, 8 are all 90 degrees. Let's draw a perpendicular transversal. Now let's name these. Line A, B, C, D, E, and F. Now let's see the corresponding angles. This angle and this angle here is a corresponding angle because they are on the same corner on each side but not on the same vertice. And this corresponding angle is both 90 degrees because this is a perpendicular transversal. Now let's point out other corresponding angles. This angle and this angle is a corresponding angle. This angle and this angle is a corresponding angle. And this angle is a corresponding angle. Now let's learn about the consecutive interior angles of transversal. When two lines are crossed by another line, the angles inside the parallel line and on the same side of the transversal are called consecutive interior angles. Example: in this figure, 2 and 4 are a pair of interior angles, and 1 and 3 are another pair of interior angles, and they are both consecutive angles because they are both inside the parallel line and on the same side of the transversal line. Now let's see the properties of interior angles formed when transversal lines intersect parallel lines. Here, angle 1 and angle 3 are interior angles, and angle 2 and angle 4 are interior angles. And when you add the consecutive interior angles, they will always equal to 180 degrees. Now in this example, let's see a figure. Here, angle 3 and 5 are a pair of consecutive interior angles because they are inside the parallel line and they are on the same side of the transversal line. And angle 3 and 5 equal, when you add them, they equal to 180 degrees. Angle 4 and angle 6 is a pair of consecutive interior angles, and when you add them together, they give you 180 degrees. Here, let's see the pair of consecutive interior angles. Here, angle 3 and angle 9 are a pair of consecutive interior angles because they are inside the parallel line and on the same side of the transversal line, and they will give us 180 degrees if you add them together. Angle 4 and angle 10 are a pair of consecutive angles because they are on the same side of the transversal line and inside the parallel lines, and they give us 180 degrees when added. 7 and 14 are a pair of consecutive interior angles because they're inside the parallel lines and on the same side of the transversal line. And when added, they give us 180 degrees. And 8 and 15 are consecutive interior angles. And when they are added, they will give you 180 degrees. Let's draw a diagram. Let's name these lines. Line A, B, C, D, and E, F. And let's point out the consecutive interior angles. This is a consecutive interior angle, and this is a consecutive interior angle because they are both inside the parallel lines and on the same side of the transversal line. Now let's see another pair of consecutive interior angle. These two are a pair of consecutive interior angle because these are inside the parallel line and they're on one side of the transversal line. Now, let's see interior angles formed when transversal lines intersect non-parallel lines. Angle 1 and angle 3 are consecutive interior angles, and angle 2 and angle 4 are consecutive interior angles. Let's see the properties. Angle 3 and angle 5 are consecutive interior angles, and 4 and 6 are also consecutive interior angles. Here, 2 and 5 are consecutive interior angles, and 4 and 7 are consecutive interior angles. Now, let's draw a transversal. Now let's name the lines. Line A, B, C, D, and E, F. And let's point out the consecutive interior angles. This and this is a pair because they're inside the two lines and they're on the same side of the transversal. This and this is a consecutive pair of interior angles. Now let's see consecutive exterior angles of the transversal. When two lines are crossed by another line, the angles outside the parallel lines and on the same side of the transversal are called exterior angles. Example, angle 1 and angle 3 are consecutive exterior angles because they are outside the parallel lines and on the same side of the transversal lines. And angle 2 and angle 4 are also a pair of consecutive exterior angles. Now let's see exterior angles formed when transversal lines intersect parallel lines. We know that angle 1 and angle 3 are consecutive exterior angles, and when you add them up, they give us 180 degrees. And then angle 2 and angle 4, when you add them up, you get 180 degrees. Let's see an example. We know that angle 1 and angle 7 are a pair of consecutive exterior angles, and when added they give us 180 degrees. And angle 2 and angle 8 are a pair of consecutive exterior angles, and when added together they also give us 180 degrees. In this figure, angle 1 and angle 11 are a pair of exterior angles, and they give us 180 degrees when added. Angle 2 and angle 12 are a pair of consecutive exterior angles, and when added they give us 180 degrees. Angle 5 and angle 16 are a pair of consecutive angles, and when added together they give us 180 degrees. Angles 6 and 17 are a pair of consecutive exterior angles, and when added together they give us 180 degrees. Now let's draw a transversal line. And now let's name these lines A, B, C, D, E, and F. And now let's see the consecutive exterior angles. These two angles are a pair of consecutive exterior angles because they are outside of the parallel lines and on the same side of the transversal line. There's another pair of consecutive exterior angles, and that is these two. These two angles are a pair of consecutive exterior angles because they are outside the parallel lines and on the same side of the transversal line. Let's see exterior angles formed when transversal lines intersect non-parallel lines. Here we know that angle 1 and angle 3 are exterior angles, and angle 2 and angle 4 are also consecutive exterior angles. Angle 1 and angle 7 are a pair of consecutive exterior angles, and angle 2 and angle 8 are a pair of consecutive exterior angles. And in this figure, 1 and 6 are exterior angles, 3 and 8 are exterior angles. And as you see, even if we add them, they will not always equal to 180 degrees. Let's draw another transversal. Now let's name them A, B, C, D, and E, F. And now let's point out the consecutive exterior angles. This is a consecutive exterior angle, and this. And even if you add them up, they will not give you 180 degrees. There's another pair of consecutive angles. This and this are consecutive exterior angles because they are outside of parallel lines, of the two lines, and on the same side of the transversal line. Now let's learn alternate interior angles. Alternate interior angles are a pair of angles on the inner side of each of those two parallel lines, but on the opposite side of the transversal line. Alternate angles form a Z shape and are sometimes called the Z angles. Example, in this figure, angle 1 and angle 4 are a pair of alternate interior angles because they're inside the parallel lines and on the opposite side of the transversal line. And as you can see, they form a Z shape if you start from angle 1 and angle 4. Angle 2 and angle 3 are another pair of alternate interior angles because they are both inside the parallel lines and on the opposite side of the transversal lines. And they also form a Z shape if you start from 2 and 3. Let's see what happens when alternate interior angles formed when transversal line intersects parallel lines. We know that angle 1 and angle 4 are alternate interior angles, and angle 2 and angle 3 are another pair of alternate interior angles. And if this is in a parallel case, alternate interior angles will always be equal. That means angle 1 and angle 4 will be equal, and angle 2 and angle 3 will be equal. Now let's see an example. In this figure, angle 3 and angle 6 are alternate interior angles. That means angle 3 and angle 6 are equal. Angle 4 and angle 5 are alternate interior angles. That means they should be equal. And here, in this figure, angle 3 and angle 10 are a pair of alternate interior angles. That means they are equal. Angle 4 and angle 9 are a pair of alternate interior angles. That also means they're equal. 7 and 15 are a pair of alternate interior angles because they are equal. And 8 and 14 are a pair of alternate interior angles. So that means angle 8 and angle 14 are equal. Now let's draw a figure. Now let's name these lines A, B, C, D, E, and F. Now let's point out the alternate interior pairs. This angle and this angle is an alternate interior angle because they are both inside the parallel lines and on the opposite side of the transversal line. This angle and this angle are also alternate interior angles because they are inside the parallel line and opposite sides of the transversal line. Now let's see alternate interior angles formed when transversal line intersects non-parallel lines. Angle 1 and angle 4 are alternate interior angles, and angle 2 and angle 3 are also alternate interior angles because they are both inside the parallel lines and they are all on the opposite side of the transversal line. And even though if these two lines are non-parallel, they will still form the Z shape. And in the non-parallel case, alternate interior angles will not be equal. Let's see an example. Here in this figure, angle 3 and angle 6 are a pair of alternate interior angles, and angle 4 and angle 5 are another pair of alternate interior angles. These are not equal since this is a non-parallel case. Now let's point out the alternate interior angles in this. Angle 2 and 7 are alternate interior angles, and 4 and 5 are alternate interior angles. All alternate angles in non-parallel cases will never be equal. Now let's draw a figure of the transversal line. Now let's name these transversal figure A, B, C, D, E, and F. And now let's point out the alternate interior angles here. This and this is an alternate interior angle because they're both inside the two lines and opposite of the transversal line. This angle and this angle are also alternate interior angles. Now, even though if this is not parallel, they still form the Z shape. If you start from this angle and to the alternate interior angle, you will see a Z. Now let's learn about alternate exterior angles. Alternate exterior angles are a pair of angles on the outer side of each of those two parallel lines, but on the opposite sides of the transversal. Alternate angles form a Z shape and are sometimes also called Z angles. Let's see some examples. Angle 1 and angle 4 are a pair of alternate exterior angles because they are outside the parallel lines but opposite side of the transversal line. Angle 2 and angle 3 are also a pair of alternate exterior angles because they're on the outside of the parallel line but on opposite sides of the transversal line. Now let's see alternate exterior angles formed when transversal line intersects parallel lines. In this diagram, angle 1 and angle 4 are a pair of alternate exterior angles, and so is 2 and 3. In the parallel case, alternate exterior angles will always be equal. So that means angle 1 and angle 4 will be equal, and angle 2 and angle 3 will be equal. Let's see a diagram. In this figure, angle 1 and angle 8 are alternate exterior angles. And since this is the parallel case, they will be equal. Angle 2 and angle 7 are alternate exterior angles, and since this is also the parallel case, angle 2 and angle 7 will be equal. Here, angle 1 and angle 12 are alternate exterior angles, so that means they are equal. Angle 2 and angle 11 are a pair of alternate exterior angles, so that means they are equal too. Angle 6 and angle 16 are a pair of alternate exterior angles too, so that means angle 6 and angle 16 are equal. Angle 5 and angle 17 are a pair of alternate exterior angles, so that means they are equal. Let's draw a transversal. And now let's name these lines. Line A, B, C, D, and E, F. Now, let's point out the alternate exterior angles. Here and here is an alternate exterior angle because they are both on the outside of the parallel lines and opposite of the transversal lines. Here and here are both alternate exterior angles too, because they are on the outside of the parallel lines and opposite of the transversal lines. Now let's see alternate exterior angles formed when transversal line intersects non-parallel lines. Here, we know that angle 1 and angle 4 is an alternate exterior angle, and angle 2 and angle 3 are also an alternate exterior angle. But in a non-parallel case, alternate exterior angles will not be equal. Let's see a figure. In this figure, we know that angle 1 and angle 8 are alternate exterior angles because they're outside of the parallel line of the two lines and on the opposite of the transversal lines. Angle 2 and angle 7 are also alternate exterior angles. These will not be equal since this is a non-parallel case. Here, angle 6 and angle 3 are a pair of alternate exterior angles, and angle 1 and angle 8 are also a pair of alternate exterior angles because they are both outside of the two lines and opposite of the transversal line. And alternate exterior angles will not be equal. Let's draw a transversal. Now let's name these lines. A, B, C, D, E, and F. And now let's point out the alternate exterior angles. This angle and this angle are alternate exterior angles because they're both outside the two lines and opposite of each transversal side. This angle and this angle are alternate exterior angles too because they're outside the two lines but on the other side of the transversal lines. Thank you for watching. Comment, like, and subscribe, and stay tuned for more videos. Bye!